All right. I'm a little bit over. Let's go ahead and get started. Before I do, does anybody have any questions about anything at all? Stuff we covered last time, how the class works, stuff that's due, anything at all? A couple things I want to bring up that I didn't emphasize enough on Monday was that most of you have done it, but there's this survey which is technically due tonight. This getting acquainted, not really about math at all, just a kind of a quick introduction between me and you. So I think the first 4 questions are about you. The last question is for you to ask me something if you're curious, and I look forward to responding to those every semester. So also easy points, the easiest points I will ever offer you. Technically due tonight. If you do it a couple days later, I'm not going to hammer you over it. Which reminds me of something else I wanted to talk about. So I have to assign due dates for things, especially web work. There has to be a closing date in the web work assignments. That's just the way that program works. The Canvas things, even though I have due dates, if you can submit them late, like it'll still take them. So even though I have due dates, if that doesn't work, I know life happens. This is not your only class. You have other stuff going on outside of school. If you need extensions for any reason, please talk to me. I'm totally willing to work with you. I almost never say no to people asking for extensions, but I need to know that you need one. Does that make sense? So, I mean, just 95% of the deadlines you're ever going to be given are negotiable. If you're coming to me every week needing time, I'm probably we're going to have a talk about maybe why that's happening, but I get that things happen once in a while. So please be open with me and we'll work together on it. I also got one question on the ed discussion this morning, which I wanted to talk to everyone about. So thank you, Pia, for using this. Is average value something that you talked about in Calc 1? Do you remember how to do it, how to find it?
Does the average value mean like taking the slope of the two values?
Here's what I hate about some of these terms we use. There's a theorem in Calc 1 you probably learned called the mean value theorem, which involves the slope of, which is annoying because mean and average kind of have similar definitions, right? But let me pull up a slide just so I can draw. So what I'm about to draw has nothing to do with what's on the slide, but I don't know how else to find white space for this. But basically, let me start by asking this. Do you know what a definite integral is? Or basically how to find the area underneath the curve. So basically, let me just draw a generic picture here. If I have a curve and I wanted to find the area between A and B, how do I do that?
So it's the integral B minus.
Right. So basically, if this is lowercase f, then I would take the integral to find this antiderivative f. And fundamental theorem of calculus says I can do that, right? Basically, what the average value does is it kind of answers this question. So I found the area of this weird shape. What if I were to replace this with a rectangle that has the same area and the same width? How tall would that rectangle be? So maybe I'll stop there. How would I answer that question? Area is base times height. So I know that I want the non-rectangle thing and the rectangle to have the same area and the same width. So basically what I'm looking for is that average height. So when you integrate, you're really looking at an infinite number of heights. If I asked you to find the average height of everyone in this room, what would you do? Add them up and divide by however many of you there are, right? So integrals, you can't really do that because there's an infinite number of things here going on. But essentially the way you find the average value and This might sound familiar and it might not. I feel like if you spent any time on this in Calc 1, it wasn't a lot. So we know how to find the area under this curve, right? The integral from a to b of f of x dx. If I want to find basically the average height, I'm going to take this thing, which is the area, and divide it by whatever the base length is, which is going to be b minus a. So basically this thing right here is the area. And this thing right here is basically 1 over the height. Or sorry, no, 1 over the base. So that's the average value of the function. That also answers the question, you know, what is this height right here? If I were to replace that area that is not a rectangle with something rectangular, what would its height be? So I'm less interested in how familiar that seems versus how much sense does it make now. We're going to be doing a lot of definite integration today, so hopefully that'll be more clear. I'll try to pepper that in to kind of give you some guidance on that part of the homework. Any other questions before we move on? Okay, so we spent, you know, other than talking about introducing the class and the syllabus, that kind of stuff, we spent a lot of time talking about indefinite integration. Now we're going to get into definite integration. But before we do that, I wanted to ask a couple of general questions. So we did a few examples last time. So let's talk about what happened. Let's talk about what we can learn from those examples, like what kind of generalizations we can make. Maybe. There you go. So when we're doing integration by substitution, how do we choose? So basically you have to start with choosing that intermediate function u. How do we choose that? What kind of things do we look for? What kind of things do we ask ourselves? Like, what did you notice from last time?
You're using a composite or inside of.
Right. So usually we have a function we can treat as a composite. And we typically use u as the inner part of that composite. Is there any example we looked at last time that didn't really follow that?
Where you did you simplify the tan to sine of the.
Yeah, that was the very last one we did. So I mean, you can really treat any function if you're careful enough as a composite. This one's maybe not as obvious as, not as obvious as, you know, a lot of the ones we did. The inner function, I remember many of you were very quick to say 1 minus 8x squared. Same here. Many of you are very quick to point out that the inner function is 2x plus 1. But I'm not going to promise you always, but that's usually a good place to start looking for these things. So after you've made that choice, what do we typically have to do with that u that we've defined?
We have to take the d.
Right. Right. So remember, the integrals are, depending on how you look at it, they're either a function of 1 or 2 variables. Yes, u is the variable, but you also have to have that differential version of it, like that small change in that variable du. So what am I asking you here that's different from anything we did last time? Has bounds this time, right? So when we were done with everything we did Monday, what kind of object did we finish with? Like, what do our answers look like?
Because of the c, which is it's like a family of functions.
Right. So it's a class of functions. It's that are all the same except for this arbitrary constant that we need more information to find the value of. What are these going to look like? Like when I get an answer for this, when I draw a box around something here, what is that going to look like?
That's so specific.
It'll be a constant. It'll be a real number. So how do we get started?
Sign the substitution in 3x.
So in many ways, what we're doing here is going to start the exact same way. So I heard 1 vote for u equals 3x plus 6. You okay with that? All right. From there, what has to happen? So the derivative of this du is going to equal to what?
3dx.
3dx. All right. So this is basically how we started everything else on Monday. So this is still common. Where do we go from here?
You can take the bounds and take the value of them.
Right. So this is something we can do too. So remember, our goal here is to take this integral and basically translate every part of it that deals with x into something that's, in the language of u. This clearly has to be transformed. This has to be transformed. But what is far more subtle is that these two things here are x values. So if we're going to transform this integral, we should transform those values as well. But how do I do that? So let's do this in pieces again. I'm going to do the integral from x equals 10 to x equals 1 to make it clear those are still x values of what? Square root of u. I'll just call it dx for now. So I want to keep transforming this integral. What's another move I can make?
Sure.
Sorry, what?
Change the radicals.
I can change the radical to exponent 1/2. So u to the 1/2. While we're at it, what can I do about that dx? Solve for it. And what is the over 3? So u to the 1/2 times du over 3. Okay. So since we haven't done this before, let's be really clear about how we're going to change these x values of 1 and 10. So I need those to be u values. So if x equals 1, what does u equal? If x equals 10, what does u equal in that case?
10 and 36.
So how did you said 10 and 36?
So if u is 10, it's 3 times 10 plus 6.
Right. So that's one thing we can. So that's another value we're getting, or another valuable thing we're getting out of u equals 3x plus 6 is that I can use that as a recipe to translate my bounds. So if x equals 1, then u equals 3 times 1 plus 6, which is 9. And if x equals 10, then u is equal to 3 times 10 plus 6, which is 36. So now we should have, I'll pull out the third. Now we should have an integral that's ready to go. And I don't really, since there's no more ambiguity, I'm going to remove those u equals. So I'll stop there. Any questions about how we got to this point before we actually integrated? Okay. Now let's keep going then. What is the integral going to be from here?
2/3 u.
2/3 u to the 3/2. I left something off. 1/3 times 2/3 u to the 3/2, evaluated from 9 to 36. Oh no, what's 1/3 times 2/3? 2/9. So 2/9 times 36 to the 3/2 minus 2/9 times 9 to the 3/2. Do these simplify at all? What is 36 to the 3/2 power?
16.
How'd you get 216?
I took the square root and then I took it to the third power.
Yeah, good. That's probably the most direct way to do it. So yeah, square root of 36 is 6. 6 cubed is 216. What's 9 to the 3/2?
7.
27. All right. Now I might need some help from one of you. Does 9 go into 216? 48. So 48 times 2 is 96. Or is 48 the final? Okay.
2 minus 10, 16. Minus 6.
6, so 42. So again, everything we did with indefinite integration got us to some class of functions. But definite integral should give you a real number. So since we talked about average value here, let's, even though I didn't ask this in the slide, let's talk about it now. So what does this curve kind of look like between 1 and 10? Square root functions sort of look like this. So this number 42, what did we really find there? Like what does that have to do with the graph I just drew?
The net change, the area underneath.
Net change, yeah. So net change area underneath. So this area that I'm shading in right now is 42. What would the average value of this function be over that interval?
2 divided by 9.
42 divided by 9. So the average value is equal to 42 over 9, which is 21. 14 thirds. So a little bit less than 5. So this 14 thirds or 4.66 repeating. Like, how can I represent that in this graph up here?
Rectangle of -1.66.
Right, basically that is what the average, or one, I mean, the average value you can interpret a lot of ways, but I think this is the graphical way. But basically, if I had a rectangle that had the same exact width, or like same exact base length of 9, and the same exact area of 42, that rectangle would be 4.66 repeating tall. Let's just visualize one more thing here. What are these y values? I think this height is 3, and this height is 6. So the average height, somewhere in between. So, any questions on this integral, how we got to the end of it, how we approached it? How about the average value thing? Which seems like it's more than a little rusty from Calc 1, or you just didn't see it.
How did you get the y values again? It's 3 and.
The 3 and 6, good question. Yeah, I didn't narrate that at all. The y values are going to come from the original function. So when x equals 1, this becomes the square root of 9. And when x equals 10 is the square root of 36. Good question. Anything else? Okay. Let's go again. So I gave you what the book calls the substitution rule for indefinite integrals last time. So what's the big change when you have an interval? Really, is the fact that you have bounds, that you have a finite length at x values to integrate over. But really, the only difference between this and the thing that I showed you on Monday is that I think I'm going to underline everything that I showed you on Monday. It's really just this. So in a lot of ways, it's the calculus that it is totally unchanged. Now you're not done after you take the integral. You now have to evaluate that new function at some endpoints. Shall we see a couple more? All right. I think I skipped the only one we had last time that dealt with exponential log stuff. So let's handle this one. How to start? What do we think?
Substitution. Natural log.
How'd you choose natural log?
Something more complicated.
It's more complicated. Okay, so maybe another guiding light to kind of look for when you're going for you is that
Or is it, when you mentioned something that the two X values somehow are kind of related in a way, they're kind of derivatives of each other.
yeah, that's what needs to happen. So let's do this. I'm not convinced yet that this is the right way to go. So let's keep looking. What do I have to do? Oh, go ahead.
I was just gonna say, if you differentiate you, you get 1/x.
Okay. So du over dx equals 1/x.
And that replaces something that's integral, so you can completely get rid of x when you.
Right.
Type in.
So I am now convinced that that was the right path because. So when you, and I think I talked about this a little bit last time, but when you do chain rule to find a derivative, you have total freedom over what to call the inner function and the outer function. When you're integrated by substitution, once we choose our inner function, the outer function has to be present, or at least some multiple of it has to be present in the thing we're trying to integrate. So just as an example, let's look at the other way. What if I said, for example, that u is equal to 1/x? Then what is du? What's the derivative of x to the negative first?
To negative x to the negative.
At negative x to the negative 2, which is negative 1/x squared. Is that a good path to keep going? Now, there's no way to account for the natural log if I go that way. So this is something you might run into. But really, if you can't make the substitution using the u and du that you have, then you have to try something else. But I think this way forward should work. So now can we start transforming this integral? Okay. How are we going to do that? So the integral from 1 to e of u over x dx. I'm sorry, say it again. Dx is equal to what?
You can substitute the dx to the du times x.
So dx equals x du. If I do that, then this becomes the integral from x equals 1 to x equals e to u du. That's pretty simple.
Change the bounds to u.
Right. So we can change the bounds. I'm going to do this a slightly different way just to kind of give you another look at this. Let's say I leave the bounds the way they are and integrate first. What is the integral of u du? 1/2 u squared. Evaluated from x equals 1 to x equals e. But something we didn't do last time is, so for the last example we did, we substituted the integral, and once we got it into u terms, we never went back to x, right? Which you don't have to, but you also can go back to x if for some reason it's easier, if you would just rather do it that way. So in this case, I would do 1/2 times the natural log of x squared. And I'm going to evaluate that from 1 to e. And we should wind up in the same place. What is the natural log of e? 1. What is the natural log of 1? 0. So this becomes 1/2 minus 0. Final answer 1/2.
Will you ever be asked to do it a specific way?
No. So the only reason I'm showing you different looks is because one of the two might make more sense for some of you and not the others. But in general, I don't like to dictate how you do a thing. Questions here? So I want to find this shaded area. Can you even see this well enough to do what I'm asking you to do? Okay, I'll fill in the blanks if you can't see it. But how do I answer this question? I want to find that red area.
The integral of that function.
So I need the integral of this function. X e to the 4x squared plus 3. What are the bounds, or can you tell what they should be?
0.
Okay. So yeah, basically I'm asking for the area is equivalent to asking for that integral. Left off something really important. How should we go after this integral? How do we go forward?
Make your substitution, maybe a phone.
Okay. So u is equal to 4x squared plus 3. And from there, what follows?
du.
Okay. Is 8x. So based on that u, is our du, is that a good result for us? Do you have a question?
Could you divide out the 8 and then you're just left with your x dx?
Right, so if I divide both sides by 8, so let's be very clear. Why did you decide to divide both sides by 8?
When you divide out the 8, because right now you don't have 8x dx in your integral. If you divide out the 8, since it's just like a constant, you just take it out. You're left with x dx, which is present in the.
Good, that's exactly right. So, and I'm glad this came up because I think what we've kind of been doing by default is finding u, getting the du that comes from it, and then solving for dx and choosing whichever one of those, but basically making the manipulations from there. But if you recognize that basically the du we have is exactly 8 times as large as the thing we're trying to replace, you can make that manipulation a little bit earlier. But again, like it does not really matter how you get from the x integral to the u one. All right, so where do we go from here?
You write your integral.
Keep those x's for now. So I believe we have, so yeah, what's the integrand look like? What's the du? I think the x has already been taken care of because. Yep. So just to, so u is here, right? And then I wish I had more colors. Basically the du over 8 is there. So really, except for the bounds, this integral has been, the substitution's almost done. Last thing we have to deal with is the bounds. So you've kind of seen it both ways now. You want to substitute the bounds or do the integral then go back to x? Substitute? Okay. So, sorry, substitute the bounds? Okay. So what are the new bounds going to be? I heard 7 and 3. Do we agree with that?
Could you show how you got
Absolutely. I was hoping somebody would ask. I knew the question was out there. How do we get 3 first of all?
4 times 0, 0, 0.
Right. So basically it all comes from this. Basically the first choice you ever made is where those new bounds come from. Basically you have come up with a function that unites u and x. So if we have constant x values, which is what 0 and 1 are, then you also have, you've already built the method to translate those into u values. So 4 times 0 squared plus 3 is 3, and 4 times 1 squared plus 3 is 7. So now this integral is it's ready to go. What is the integral of e to the u du? E to the u. So 1/8 times e to the u. If someone wants to give me the approximate answer, they can, but otherwise I'm gonna leave it like this.
On the exam, can you just leave it like that or? You want to?
So I'll answer this two ways. For my homework, I don't care. I think it's very rare that I specify how to answer it. And pretty much if I do, it's almost always exact. Which means the calculator won't get me what I want. From experience teaching this class last semester, the exams almost always want the exact answer. Which means that's right there. The thing I boxed in is perfect. So keep an eye out for that. The test that basically we use as a coordinated class usually specify exact. I don't usually specify it one way or another.
Scantron?
No.
Oh.
They're multiple choice, but they're not Scantron for some reason. And actually, I don't want to promise a multiple choice. They might not be, but they were last semester. So last semester, I think the typical like in-class exam was like 8 multiple choice questions and 3 free response ones. So I would expect that. I don't want to promise that it'll be that way again, but probably similar. Any more questions about this? Go ahead.
You did it a little bit ago, but when you were solving in terms of X, I'm kind of confused on how we got that in terms of X.
For the last example?
Yeah, for example, 2.
Okay. Okay, so I think you're talking about how we got from this step here to this one here.
Yes.
Okay, so I know that my integral, basically after I integrate, I get 1/2 u squared, right?
Oh, so you just plugged ln of X.
Yeah, so basically I just undid the substitution we started with. Good question. All right. Okay, last one for you. How we doing? Oh, go ahead, sorry.
So for the last one, this is the area? The,
That is the area, so, and this is probably. I'm not sure what kind of things you learned in Calc 1 that you could do with integrals, but I'm sure area was like the main one you talked about. No? I guess I shouldn't assume that everyone took Calc 1 just a few months ago. So, and I feel like
It's like basically.
a lot of math teachers aren't super careful with it, and I'm probably got to include myself there. But antiderivatives and integrals are not really the same thing, but they are very closely related. But I'll be more specific here. Probably the quintessential thing you learn to do with definite integrals is to find areas between vertical lines and underneath curves. So, and that's really what I'm asking here. Not totally obvious because the left side of this curve is the origin. And the right side's definitely a vertical line. But we have a definite interval between X values, which are 0 and 1. And we have that ceiling function. Basically, I want to find the area below this function above the X-axis. So that is something that you probably did a little bit in Calc 1 just because you didn't cover a ton of integration. But we'll do a lot of that this semester too. Another big thing we do with integration is, I know someone kind of alluded to it before, but basically finding the net change of things. So, and to explain that in more detail, let me ask this. If you have a function and you find the derivative of that function, what does the derivative tell you? Rate of change, right? So if integration is the inverse process, then that means I can know the rate of change of something and how long it's going to change like that, and integrate that to tell you what that change is. So that's essentially what I'm asking for now. So I have this storage tank with a leak. And what does this function right here tell me?
The rate at which it's leaking.
The rate at which it leaks, right? So if I integrate that over a period of time, that'll tell me what? How much it leaked out, right? Another thing to look at here is the units. Liters per minute. So I'm going to integrate this thing over a certain number of minutes. And that'll tell me how much oil I lost over that period of time. So a lot of the pieces are here, but we don't have an integral yet. So can we set up that integral?
Yeah.
Yeah, let's do it. So what are the things we have to fill in?
Ounces, 0 to 60.
The bounds are 0 to 60. Why not 0 to 1?
Is it then liters per minute?
Liters per minute, first hour. So yeah, I communicated time to you in 2 different ways. So we have to bring some consistency there. So the bound should be 0 to 60. Good, what else?
Function.
Okay, so I'm going to integrate the rate function with respect to time. So the integral from 0 to 60 of 100 e to the negative 0.01 t dt. Questions on the setup, how we got this integral? Okay, now we have to evaluate it. So what do we need for that? Need a u. It's a good u. I think I heard someone mutter the word exponent.
0.0 t.
I agree with exponents. That is, I never like to promise always because I'm paranoid, but when you have an exponential function, that's a good place to start, is to use the exponent as a place to start your substitution. All right, if that is u, then what?
Why do you include the DT in the U?
I don't. I did it because I made a mistake. Good catch. No, it should not be there. All right, so there's the u. Then what? Okay. What is du? Negative 0.01. dt does go here. Okay. Is that a good u and du to go forward? Yeah, so we just like most times you have to figure out what that constant multiple is, but I do believe we have a constant multiple. So the integral from t equals 60, or t equals 0 to t equals 60 of 100 times e to the u dt. So we have a few more t things to get rid of. So how do you want to do that?
You can
Multiply
you
both
can
sides of
solve
the
their DT.
Okay, I heard multiply both sides of du
by
but
10,000.
by 10,000. How'd you get 10,000?
100 divided by 0.01.
Okay, good. So if you multiply both sides by 10,000, let me make that clear.
Oh,
What's-
yeah, negative.
Negative 10,000. So multiply both sides by negative 10k. So that becomes negative 10,000 du equals. Oh, that was the point. 100 dt. Okay. So now that we have that, I believe this just becomes, so the one, now I have the 100 dt, so this becomes the integral from t equals 0 to t equals 60 of e to the u du. So we have some choices on how to go forward. What do you want to do now? Did I?
Shouldn't that go outside the?
Oh, yeah, absolutely right. Yeah. I'm going to try to squeeze that in. So equals negative 10,000 times the integral t equals 0, t equals 60 of e to the u du. Okay, thank you. What would you like to do next?
You can take the U values or you can,
When you wanna just plug it in, would that be easier?
Plug it in right now.
No, you would have to take it.
Right, so that's one thing I want to point out because I think that's, I know that temptation is strong for a while. So yeah, I've got to integrate before we do any evaluating. In this case, you would kind of get away with it, but you usually would not.
or you just.
Why do I say you would get away with it here?
So you just-
Yeah, the integral is equal. So yeah, I mean, I think that's the choice. So what would you like to do? Translate the t bounds into u bounds, or integrate e to the u and translate it back to t stuff?
You can just integrate your system.
Okay, so then this becomes negative 10,000. Actually, we should do the bounds then, right?
How do you know when you're supposed to do the bounds and when you're supposed to say?
That's kind of the point that I was getting to. It does not matter.
It's just-
It very much is a choice as to what you'd rather do. In fact, maybe I should drive that point home by doing both. Do that. So on this side, let's translate the bounds. So if t is equal to 0, then what is u equal to? 0. And if t is equal to 60, what is u equal to? Negative 0.6 of e to the u du. That's equal to e to the u, evaluated from negative 0.6 to 0 to negative 0.6. So it's weird to have the lower limit or the lesser value as the upper limit, but that's where we are. So this becomes e to the negative 0.6 minus e to the 0.
Still need to multiply it by negative 10,000.
Yeah, I left that off again, didn't I? Huge number I keep forgetting about. So 1,000 times e to the negative 0.6 minus e to the 0, which is 1. And because I'm going to compare these answers, I probably should ask one of you to calculate this and give me a approximate number.
11.28.
Okay, sounds good. All right, so that is if we transform the bounds first. If we go the other way, then I am going to, let's just write down the integral first. Negative 10,000 times the integral from t equals 0 to t equals 60 of e to the u du. Integral of e to the u is e to the u, right? But I am going to do this. I am going to not write e to the u. I'm going to write e to the negative 0.01 t. And now because of that, I don't have, so now I've got my function back in terms of t. So I don't have to do anything with the bounds because they're already written in t. So any questions about the two different things we're doing here? Go ahead.
Isn't it the same thing where like, if your bound is smaller on the top, then it just switch the sign?
You don't have to. It's totally okay for the bound on top to be small.
Okay. So
It probably hurts your eyes. It's weird to see it like that, but it's mathematically totally acceptable. Okay, so this comes to be negative 10,000 times e to the negative 0.06. Actually, this didn't really have to approximate it, did I? Minus e to the 0, which is 1. So basically, kind of both the approaches we took for like the end game here. If you do them correctly, you're going to wind up in the same place. So it really is about what you prefer, what makes more sense to you, what makes more sense for that example. But
What's the difference between the exponent on the e being negative 0.6 and negative 0.06? Would that not change the answer?
it absolutely would. I didn't get a lot of sleep last night. Good catch. It should be 0.6, right? Yeah, I just. Okay, is it almost time for me to stop embarrassing myself? Cool. Any other questions here? To answer your question about having integrals with lesser bounds on top, let me draw a very small picture up here. Let's say I integrate this curve from A to B. How is that integral related to this one? Or do you have any idea? So this is probably maybe something you talked about, but the integral from A to B of a function is exactly equal to the opposite of the integral from B to A. So you'll notice here that when we did this integral in the lower left corner here, we have the lesser value is the upper bound, but this function e to the u is positive. So we're going to get a negative area out of that, which doesn't make a ton of sense, maybe intuitively or geometrically. But that's why the multiplying by negative 10,000 brought it back to positive. So again, it's totally legal to have the upper limit of an integral be greater or be lesser. May not act the way it's weird to think about in terms of area because you end up getting a negative area. That is all I have for you from section 5.5. I don't want to get into 6.1 with just a minute left. Any more questions before we head out? All right, we'll start 6.1 next time. No. Yeah, I'm gonna head home, but so no, I mean I'm not in a rush or anything, but yeah, if you're okay posting it there.
Yeah.
Yeah, it's okay, cool, yeah. I don't think it's due for a while.
Since once I knew that we were looking to start kind of trying to get rid of all the complexity in this.
Okay.
I don't know if it's like,
Find something.
it's a lot.
We're
Some of them
from
are
way different than how it's supposed to, it's like real, because I'm just like, wait, it's like.
Oh.
Work, so there's a little bit of kind of.
I didn't see the interest rate function there, but not that you can't do it, but
Yeah, there was one or two.
Okay.
At least one. But anyway, I was supposed to.
yeah, so the biggest reason I'm gonna ask you to post it there is because I know you're not gonna be unique in having that question. So yeah, I think I know what's cool. What's stopping you?
I'm just confused with where back to negative.
And then it looks like.
Yeah, that's great.
It's literally.
So
taking it out of the problem.
what someone realized here is that
Well,
our u is negative 0.01 t, right? Which means our du is negative 0.01. So we have basically this is a 100 is a constant multiple. So basically 100 dt is a constant multiple of the du we have, right? So someone found that ratio by dividing 100 by negative 1.
Opposite.
That's why I was like, that is a lot.
So
Depends on the use that, but it's just with the TA. I think it's 35.
100 divided by
One.
0.01.
It's not, it's not too bad.
So,
Some.
but here's the thing, that is, if you notice that, that's a perfect thing to use. But if you don't, like, the thing we've done for a lot of these examples is we solve for DT.
You didn't care.
Does that make sense?
So DT divided by, sorry, DT equals DU over negative 0.01.
Yeah.
That would give you DT equals negative 100 DU. So that's also a good way to kind of get to the end of this.
Well, if there's a way where we like take the multiple out, we can just add it to the equation.
Yeah, basically what we did here is, so you okay with how we got that U
Yeah.
and how we got this DU?
Yeah.
I mean, essentially, you can multiply both sides of this equality by whatever constant you want. It's just that someone noticed that negative 10,000 was the most direct way there.
Okay.
But basically dividing it by negative 0.1 or negative 0.01,
Is how we got the little.
that wouldn't get you to negative 10,000, but it would give you like going forward. So can I go back to this and draw it again? So if we take the approach we've kind of usually done, so that would give me du over negative 0.01 equals dt, or dt equals negative 100 du. So if I have that, then down here I can plug in negative 100 du for dt, right? Then that would give me a negative 100 times positive 100, which is negative 10,000. Yeah. So basically, there's a lot of ways that you can like choose to go right there. Somewhere or another, you're going to get that negative 10,000.
Yeah, okay.
Yeah.
Yeah, I was just confused. I don't know where that number came from.
Yeah, and that's why you won't always notice that. But so you won't always notice that. But solving for dt is something you can always do.
Thank you.
Mhm.
Thank you.
Yeah, of course. See you guys.